Okay, so is matter around us pure? A little bit of how this chapter is structured is first we look at the classification of matter. What are the different types, compounds, mixtures, elements? How are they all different from each other? Different types of elements, different types of mixtures, all of that. Then we look at each of them one by one. So we'll be focusing more on the mixtures part of it. We are not looking at elements and compounds right now. So elements and compounds we'll learn more about in atoms and molecules, because that's what elements and compounds are made of. Okay, and apart from that, in this chapter you also have like different methods of separating mixtures, which I think is not it has been deleted based on CBSE's this thing. So we can go over it roughly if you want, but otherwise, like we can pick it up as and when. But today we'll be looking at the rest of it, which is just the classification of matter. Okay. Note down this chart first, and then we'll go over each one by one, each term, each word. Right. Kushagra, where are you? Your video is not on.
Yes, ma'am.
Neve? So we will talk about matter. So matter roughly, it can be divided, like the first step of classifying it is whether it's a pure substance or is it a mixture. So what is the difference between pure substance and a mixture? Like, what do you understand from it if you look at the terms?
Ma'am, a mixture is like when two elements are mixed. For example, a salt is a mixture of sodium and chloride, and a pure substance is like pure. No, I'm not sure about.
Jaideep, your definition, your understanding of it is correct, but the example you gave is not the correct one, which is what we'll be looking at now. Okay, so it's right there in the name itself. Pure substance is something that's pure. It's not made of two different things. Okay, so it's made up of only one single thing, and it's like completely that thing only. It's completely pure. Mixture is, yeah, when two different things are just mixed with each other. They're just like chilling with each other. Okay. So examples of pure substance. Let's look at some examples. From your understanding, can you guys give me 3 examples of pure substances? Can give more also, but I need minimum 3.
Hydrogen, helium, lithium.
Hydrogen, helium, yes. Hydrogen, H2, hydrogen gas. Helium is represented by He, lithium. I can see that you learned your periodic table. Can you identify any pure substance from around you? Like lithium, helium and all, you wouldn't have seen. Helium maybe in balloons or hydrogen. Lithium, not, I'm sure you wouldn't have seen it in pure form. So give me some examples from around you.
Gold.
That's a good one. Yes. Gold.
Lead.
Huh. Yeah.
Lead.
Lead. Yes. Lead is represented by Pb. That's the symbol. But you shouldn't have lead around you.
Not like this pencil, so.
That is called a lead, but it is actually made of carbon, which is also a pure substance. That's pure carbon. It's in fact the form of carbon is graphite. So diamond is one form of carbon and graphite is another one, which is what you find in pencils. Yeah, Shaila.
No, I actually forgot. There are two types of carbon, right? One is which one you use for pencil and I think for moderators. I'm not sure. I can't remember. I studied it last year, but I can't remember its name.
No issues. You'll have it next year, but you're right. So graphite is the one used in pencils, used in electrical stuff also. Graphite is like you have graphite electrodes used in electrolysis and all. Then you have graphite is also in like used in lubricants like grease, the black color thing that you see. So
That's
that
because of some kind of the molecules I think are not very well connected or something, so they slide over each other.
yeah, it's all in the structure of it. And the other form of carbon, another form apart from graphite is diamond. Like it's literally the jewelry wala diamond. That's pure carbon, elemental carbon. Okay. So it's all in, how the carbon atoms are interacting with each other. So that also how the bonds are being formed between the carbon atoms itself will decide whether it's a graphite or it's a diamond. Okay, so these are all good examples. Some more.
Water.
Huh?
Water.
Water. Yes. Water is a pure substance or a mixture?
A mixture.
No, water is actually a pure substance. So water is represented as H2O. It is made of hydrogen and oxygen atoms. You might be confused, okay, like it's like you can see different things, different atoms are there in water, but why is it a pure substance and not a mixture? Water, like water is water, like it has the properties of water. It's being wet, dissolving things, like whatever water does. That happens only when hydrogen and oxygen combine with each other, and it needs to be a chemical bonds between them. If those chemical bonds are not between them, then it's not water. Then you have individual hydrogen gas and oxygen gas. Okay, so that's why it's a pure substance. Like water is made of molecules. One molecule is one unit. Like, yes, if you look at the molecule, it is made of two hydrogen atoms and one oxygen atom, kind of looks like this, where hydrogen's on the end. This is the oxygen atom. But if you break this apart, it's not water anymore. So if you take 100% pure water without any impurities or anything, you will only find these molecular units of H2O. That is why it's a pure substance. Now, what is the difference between like something like water or something like NaCl? That's why I said the example that you used, salt, which is NaCl, sodium chloride, is also a pure substance. Now, what's the difference between things like water and sodium chloride versus mixture? Like, why are they not mixtures? So mixtures are when you're mixing two things, but there's no chemical bond between them. It's literally mixing two things together, and then both the substances are chilling with each other. There's no chemical bonds between them. They're not interacting with each other at this level. Like if you look at it under a microscope, like if I have a tank, or if I just look at air around you has so many different gases. You have nitrogen, you have oxygen, you have carbon dioxide, you have like if you're going out on the road, you'll have like oxides of nitrogen, sulfur dioxide, all of these gases are there, right? You have water vapor also, H2 is also there because it's raining pretty heavily. Now there's no chemical bonds between them. Like all these molecules are there, but they're just chilling with each other. They're just chilling around. Like, so the difference between a pure substance like water, NaCl, like all of these are called compounds. A difference between compound and a mixture is, mixture may you have like, imagine a classroom. Like you guys are going to school, classroom may all of you are there, right? Now
Yes, ma'am.
you're all just in the same place at the same time. So classroom is made of so many different students, like all of you. Like you have Jaydeep, you have Rashmit, you have Jay, you have Shaila, like all of you are there just staying in the classroom. But if you look at each student in that classroom, like if you look at yourself, okay, this is like a very bad example, but this is what I can think of now. Like you're made of two hands, two legs, you have a head, and you have a body. Right? Obviously, a hand and a leg are not the same as each other. They're different substances. But you're all like, they're all connected to your body and they form a part of you. Right? So that's kind of the difference between compounds and mixture. So compounds may, you have atoms that are chemically bonded to each other. And they're also like, if you take two atoms of hydrogen, attach it to an atom of oxygen, only then it's going to be water. So this composition, this ratio also will never change. If you change this, it's not going to be water anymore, it's going to form something else. Now that's not the case with mixture. Like sometimes you have a lot of water vapor, sometimes you have very less of water vapor. Cities may you have like pollutants in a higher quantity, carbon dioxide, sulfur dioxide, all of these. If you go to a less polluted area, if you go to the forest side, if you go trekking, or if you go to the countryside, you're going to have more of nitrogen, oxygen, and possibly carbon dioxide, like less of nitrogen oxide and sulfur dioxide, right? So mixture of the same things can have different amounts of these individual things. Mixture is simply put two things together and then, yeah, it's just a mixture of those two things.
Ma'am, but then if you mix water with water, will it still be considered a mixture?
If you mix water with what?
Water.
No, because end of the day, if you look at it, you just have water,
Okay.
right? If you have two different things that are not combining with each other, then it's a mixture. Okay. So pure
But
substances.
ma'am,
Hmm?
if one of them is distilled water and the other is impure water, then it will be considered a mixture.
Yes, but it's not a mixture of two different waters. It's a mixture of water plus whatever other impurities are there.
Okay.
Just that you're increasing the quantity of water in that, but yeah. So the distilled water is not considered separately. That's also like water only. Okay. So yeah, so based on whether it's made of atoms of the same type or different atoms like hydrogen, helium, lithium, if you take a block of gold, it is made of gold atoms only. But if you take carbon dioxide or water, you find different types of atoms there. So depending on what it is made of, pure substances are differentiated as elements and compounds. Here. So both elements and compounds are pure substances. To figure out whether it's an element or a compound, you need to see how many different types of atoms are there. So if it has only a single type of atom, like hydrogen gas, oxygen gas, you have nothing but oxygen atoms in it. Gold, you have nothing but gold in it. If you take an iron block, you have nothing but iron in it. That way. Compounds, if you have different types of atoms, but they're all chemically bonded to each other, like water, carbon dioxide, sodium chloride, which is table salt, made of sodium and chlorine, but there's a bond between sodium and chlorine, which is why it's a compound. And can you guys name any more compounds? Think of anything?
Ma'am, ammonia.
Ammonia, yes. formula is NH3.
Sodium hydroxide.
Yes. Sodium hydroxide represented by NaOH. So sodium is Na, depending on what it is joining with chloride hydroxide. This is sodium hydroxide. Nice. Good. Okay. So all of these come under compounds. Carbon is one. Lithium पहले जो बोला था apart from that. Nitrogen. Okay. Now mixtures, depending on again, mixtures also can be classified into different types. Okay, let me know when you guys have noted down pure substances side of it. Then we'll look at mixture side of it. Just like note it down. If you haven't noted down the examples yet, there are going to be more things under mixture. So just like manage your space based on that. So I'll just erase this for now. Right. So air is a mixture. Fruit salad, pure substance or mixture?
Mixture.
Mixture. Yes. Let's do we have sugar water, salt water, sea water, which is
A
basically
mixture.
salt water. Yes. Yeah. Soil is a mixture. Soil has different types of, like, you have sand, you have mud, you have stones. You also have like organic stuff like insects and leaves and stuff like that. So once we study about mixtures in detail, then we look at specific differences also between compounds and mixtures. So from sugar solution, you can extend it like lemonade is a mixture. Lots of examples. Right. Neve and Kushagra, where I can't see you guys. Where are you?
Yes, ma'am.
I'm in the. Okay, now.
Okay. Right. Let me know when you guys have finished writing, then we'll go to the next part.
Yes, ma'am.
Yeah. Okay. Anvesha, what about you?
Yes, ma'am. Done.
Okay.
Done, ma'am.
Rashmit?
Yeah, I'm done.
Okay. Kushagra, what about you?
Yes, ma'am. I'm writing.
Writing. Okay. So Kushagra, Shaila, Neve, Jyoti, let me know when you guys are ready.
I'm done.
Yes, ma'am.
Okay. Neve and Shella.
Ma'am, I've written it.
Oh, okay. Finish. Okay. Neve is also done. Cool. Right. So mixtures can be divided into we have homogeneous mixtures and heterogeneous mixtures. Right. Have you guys come across these sort of terms before? Homo, hetero, science may?
Yes, ma'am.
Okay, what is the context? Where have you come across it?
Ma'am,
in sixth grade.
homogeneous mixture is when it's the same substance.
Same substance nahi. Mixture matlab you by default mixture itself means that you have two different substances. But same something. Nahi, not in mixtures, but homo hetero, like this difference you come across it quite frequently in science. That's why I was asking if you guys were familiar with this. Homozygous, heterozygous, or something like that, like something else. No? Okay. Never mind. It's okay. So whenever you come across these terms, wherever you get homo hetero as types of something, it means the same thing. Homo means same or uniform, and hetero means different or not uniform. So in the case of mixtures, homogeneous mixtures means when it is mixed uniformly, completely throughout the mixture. So for example, think of salt water, salt solution. If I take a glass of salt solution, can you figure out ki, oh, ye pura pani hai, and then salt is like concentrated at this particular part here. Like, do you ever get that sort of a situation?
Yes, ma'am. I couldn't hear.
So when you mix salt and water, what happens?
Ma'am, the salt goes in the empty spaces, the vacant spaces present between water molecules.
Do they have like a preference that they will fill up like one small space here and then leave the rest of it alone? Aisa kuch hoga? Yeah. Like, can you drink?
No,
Yeah. So salt basically spreads itself throughout the water, right? And from like if you have a whole tank of salt water, from whichever side you pick water, it's going to be equally salty throughout. So that sort of a mixture is homogeneous mixture, like something that's like evenly distributed, pura, completely. Heterogeneous is not like that. So heterogeneous means it's not evenly distributed. It's like the opposite of homogeneous. So if you take fruit salad that's not like properly made, you can have a situation where all the grapes are on one side and then the rest of fruits are like randomly placed. Aisa bhi ho sakta hai, right? So that
Yes,
sort of a mixture is heterogeneous mixture where it's not uniformly distributed. Okay. Another example is if you like think of muddy water. So if you take a glass, like if you take a beaker or cup of muddy water, like when you're gardening or whatever, what happens to all the sand or mud?
ma'am, the sand settles down.
Settles down. Like you have a clear boundary key. Okay, sand is not over here, sand is only over here. It's concentrated only here, right? So it's not evenly distributed. It is uneven distribution. So that sort of a mixture is heterogeneous mixture. Okay. So homogeneous mixture, like one way of defining mixtures or classifying mixture is homogeneous, heterogeneous. Apart from that, you also have true solutions And heterogeneous में you have colloids or colloidal solutions, and you have suspensions. Yeah, I just draw a line here, differentiated. This chapter is quite fun. Part of the thing is like the only thing you need to be careful about is you need to know the definitions of all of these things. So we'll go over each one by one in a list, so don't worry about it. And the fun part is that like a lot of these cases you get to use it in your real life. Like a lot of these examples and all, you get to do it in your real life, figure out whether that's a compound or a mixture or homogeneous or heterogeneous and all that. Okay, so finish noting this down. I'll be right back. So we'll do some experiments. Like this is something you guys can try to do it at your home after class also. Okay. So in the meantime, I'll start setting up for this experiment. Okay. Be back in about 10 minutes.